verifability to project in water-sensitive cities. And this presentation about non-market valuation of living streams in new suburbs. So the outline of this presentation is, I'll talk a little bit about non-market valuation, why is it needed, what kind of methods do we have to do non-market valuation, why do you do this study, that's what Shelly just told. We'll talk about study area, what method do you use, what result did you get, and like we try to answer questions. As we answered more, we had more questions, and maybe it's not in any way final, so I would be really grateful if I get some feedback from you and suggestions. So if you do good projects, public projects, we would like these projects to generate both private and public benefits, and for that we do cost-benefit analysis. So we take cost, take benefits, compare if is project or is our cost lower than benefits, and then if you have several projects, which project to select if you have different cost-benefit ratio or net present value. And in water-sensitive urban design sphere, a lot of projects have the benefit of those projects don't have market values. So it's a challenge how to incorporate those benefits into the cost-benefit analysis, decision-making about projects, and for that there is non-market valuation. There are several ways to do non-market valuation, or estimating non-market values of different benefits that are generated by different projects, like living stream, for example, or park, or something else, or, for example, clean water in Swan Canyon River. And like there are several groups. One group is stated preference method. We ask people how much they would pay for certain benefits. So, and within that, there are contingent valuation. We directly ask people, and there is choice experiment, more sophisticated method. We just compare different bundles of benefits and costs. And there are real preferences method. We observe what people do, how do they behave, how much do they pay for things which do have value or prices in the market. Trade in the market have market prices, and we then try to proxy those behaviors or prices they pay to things which don't have market values. So, and those two examples of methods would be hedonic pricing method, which I will be talking about, and travel cost analysis. And then there is also benefit transfer method, which if you have values estimated using those first two groups of methods, we can transfer those values to something we are interested to know what is the value if you don't have time or money or resources to do proper kind of valuation. So contingent valuation, the stated preference method, we ask people how much would you pay, like would you be willing to pay additional $100 in your water charges if you would have this improvement of some public open space, or this constructed wetlands. And if you don't, so if you do or not, we ask different levels, and then we construct, apply some econometrics and extract values. Choice experiment is, there are bundles of goods, and for example, so there are animals, there is soil quality, there are some amenities like branches, and there is cost to you. And there are two different choices with different levels of these goods, benefits, different costs, and you ask to choose which one you prefer. And we ask it several times, several people, or many people, and we can extract what is the value of each of those attributes which don't have values. And then there is hedonic pricing method. So we assume that people do trade houses on the market, but we assume that price of house consists of prices of attributes, like how many bedrooms, bathrooms, when it's built, the area of lot, and some amenities like whether it's close to the park, how far, or whether there is some industry next to it. And then when we know what is the characteristic of houses and we know what is the prices people pay for them, we can then analyze this sales data and get values of this park, for example, being close to the house, or this negative value of this industry being close to the house. So, and then this benefit transfer, we know some unestimated value of park, for example, and then we apply to some other new project, which will be construction of similar parks. And we have different methods to adjust. Okay, and then like really quick recap of this, we made a movie. Have anyone seen this movie? Do we have a movie? Cool. Okay.
Hi there. We're environmental economists from the Centre for Environmental Economics and Policy. We value things that do not have market values, like water quality. If you live in Perth, then the water quality inside a community was considered important. Yes, it really affects me when our blooms occur. It ruined my canoeing weekend. Can we value that? Sure. It can use prices people pay to buy houses.
People pay a lot to live close to the river, but when the water is green and smelling, they pay less than when it is nice and clean.
Using the differences in prices, we can calculate the total loss due to our blooms.
Or we can ask people how much they are willing to pay to improve water quality or to improve vegetation.
That way, we can calculate the value for people who don't recreate or live near the river.
And this sort of information is very useful when making decisions about spending money to improve the health of rivers.
For example, working out if it's worth constructing a wetland to reduce nutrient pollution.
Okay, that's all movie. Okay, living streams. Okay, so living streams, you probably much better know of what is living stream than us. This is so basically retrofitting some stormwater management infrastructure, like drain into something which looks more natural, and it not only perform its function as water delivery from the suburbs to the river, for example, but also do some other functions, like there is amenity values, there is biodiversity values, there is water quality improvement, and other. And if you want to know whether it's worth to build this living stream or not, we would like to know what is the value of those amenities. And you know about this project of living stream Bannister Creek, which was started in 2000, and we did use hedonic pricing method. So this was before construction, and that was 13 years later, same spot. So we estimated that. So this is history of this in the 60s, 2000, just before construction. This construction started. This is like vegetation develops, and then it's completely functional ecosystem. So we use hedonic method, and we estimated that within 200 meters of this project, after 10 years, houses have values of about 4.7% higher than they would have if the project was not constructed. And knowing what is a median house price, for example, we can estimate, and knowing how many houses, we can estimate what is the benefit of this to the residents. Okay, and that would be about $19,000 per house. Okay, and that could be used to justify, for example, construction of these projects. But, so there are issues. We try to apply this estimate to do benefit transfer for one of the future projects. As Shelley mentioned, there are questions that this specific case, it's established suburb and it's retrofitted living stream, while in many new projects, those living streams are new infrastructure. And many things are different, the housing stock is different, the demographics is different, the density, the availability of other public open space is different, so the price might be, the impact might be different in magnitude and in extent. For example, we're talking about 200 meters, but we talked with, that's what we assumed here, extent, but we talked with professionals and they tell that no way this living stream in new suburb would be impacting house prices in 200 meters. So we decided to see what can we do. So we found one, so that's what motivation I just told. So it would be, the impact of water-centered infrastructure is heterogeneous, and we probably need to have case-specific studies to know better about what is the value of infrastructure. We found, okay, so the goal of this project is to estimate amenity value of living stream in newly established suburb using hedonic pricing method. And specifically, we wanted to look what is the spatial extent of this impact, like how far does it actually go for 200 meters, and then does it different? Is living stream different than public open space and other types of public open space? There are many. There are just regular parks. There are bush. There is sport fields. There are wetlands, natural. Also, okay, just coincidentally that in new suburb, a lot of residential lots are sold. So it's interesting. Does this value of or benefit of living stream or public open space, is it factored in the value of residential lots which are sold? And another question is temporal aspect. So in some cases, this suburb developed and living stream is built in the same time or even after the lots sold or some of the houses are sold. Would you observe that price of the houses would increase after construction of living stream, or maybe it's not necessary? It's enough for buyers to know that living stream will be, or some other public open space will be developed in this place to already pay for this high price. So our case study, we found luckily several suburbs in the Southern River catchment, Harrisdale and Piara Waters, and they are built after 2007. So they were subdivided, and a lot of lots were sold, and then there was resale of houses, and there is good infrastructure of public open space, and some of them are living stream because the topography, I guess, demands that this would be there would be good drainage in this area because it's low and it's flat. So this is what it looked like in 2008 before most of the construction is 2018. And still there is some development not finished, and some of the public open space and living stream are still being constructed. So what we did, we collected some data. So we got data from cadastral data sets, separated public parks or reserves, which would be public open space and living streams. We did classification. We had some consultations with professionals, with Shelley, for example, what do we consider living stream, what is not living stream, and then we got some input from them that it's not just living stream or park, it's also, they introduce this term of activated or not activated. Activated, we assume that that would be public open space which has some infrastructure, like playgrounds, equipment. Does that make sense? Okay. And so we added this to our, I guess, question which we want to ask. We got some GIS data about location of houses. We calculated distances to, so once we had classification of the public open space, we calculated distances from each of the houses to each of the types of public open space. We got data, sales data from one of the private companies. And we did some analysis, specifically regression analysis of these data to estimate what the impacts of different types of public open space in different distances on our house prices. And these are examples. So obviously, let us know if I got it wrong or we got it wrong. This is what we consider non-activated living stream. Just living stream, and maybe there is sidewalk, but in this activated there is some for activities, equipment or infrastructure. And same thing with the parks. And this example where we actually, so this is like piece of public open space where we separated, we consider this part of the park, and this living stream, and both are activated. Any questions so far? So this is what Salome did classification, and because of there are many types of public open space, we lump them together. We have separately living stream and separately all other types of public open space, which would be parks, sport infrastructure, wetlands, and bush. We because there is not enough observations to analyze all of them separately. But we are interested in living stream. So blue would be living stream, and light blue would be just, and dark blue would be activated living stream. Light green would be other public open space, and dark green would be activated other public open space, mostly parks. And then dots would be houses or lots. So black would be within 50 of other public open space, gray would be 50 to 100 meters, and we looked at how far this impact would be, and if you took about 100 meters, you would have half of the lots or houses in this area would be within 100 meters of public open space. So going farther doesn't make sense because we would have everything covered within 200 meters, for example, almost. And so we looked at within 50 meters, and within 50 meters would be as if you'd be immediately adjacent to public open space or living stream. And within 100 meters would be like second row, kind of.
Can I just ask a question on that?
Yes.
Did some work about 15 years ago on a big estate down south comparing pocket open space versus linear open space.
Yeah.
And the impact of the open space on the residential area depends on the orientation of the streets leading to the open space. So if you put your roads perpendicular to the open space, the influence and the experience and the property values go up those side streets. But if you put your streets parallel and you go one block back, there is no impact.
No.
So I'm just wondering, in your research, have you looked at properties that are 50 metres line of sight to open space? Because that'll be different to properties that are 50 metres physically away in one street.
Take a look at this. And then this is statistics of, okay, so we have about totally lots and houses, about 10,000 observations from 2007 to 2019, 3/4. So for houses we have these characteristics: median price 435 in 2019 prices. Median area would be 500 square meters, 4 bedrooms, 2 bathrooms, 2 car parks, 4 years average age, like from 2007 to 2019. And then for lots we just have price and size. And price will be 235, this is maximum, is kind of suspicious. And 448 is median size of lot. And lots are not much more because they sold as lots in the suburbs, and then they built, and these mostly would be probably resell. So when you look at, okay, that's also interesting to look at this aspect because I didn't see many studies which looked at lots. So and these are statistics of, okay, I'm not sure which one is more convenient, this in numbers or in percentage. So there are lots would be 7,200, and these are proportions of different kind of proximities to living streams as proportion of this number, and these are houses, and these are proportion and total. We have approximately the same distribution of houses and lots as far as proximity to different types of public open space activated. So this is within any public open space, 36%, within 50 meters, okay, about the same. Within 50 to 100 meters, about the same. Out of that, living streams, about half. Like adjacent to living streams, about half of those. And also out of all public open space, about half would be adjacent to public open space is a living stream or other which has some like recreational infrastructure which are activated living streams or activated parks. Okay, so you see within 100 meters you would have more than half of houses have like two-thirds of houses are within 100 meters of some public open space. Okay, and this is equation. So we use log price, which means that okay, we assume multiplicative effect of our impacts. So, for example, area. Interpretation of coefficient, if it's within 50 meters of public open space, this coefficient is by how many percent price increases of a house. Okay, percentage price increase for all the, so this is log of house price, and these are variables. House within 50 meters of any public open space, house within 50 to 100 meters to any public open space, house within 50 meters of living stream, and it kind of overlaps, because some of those would be also these, within 50 to 100 meters of any public open space, or living stream which is also overlap with this. Okay, I guess I didn't include also this activated. Oh, this activated. This is if. No, I didn't include it. Okay, anyway, property sold after POS is constructed. Another interesting variable. So, by the construction of, we looked at the map and near map and looked at when POS or living stream was constructed, and we record date, and we have date of sale, and we record whether it's sale after or before construction of living stream. And we know that when they sell, there is a plan, and there is plan. People know whether it's like sold next to future public open space or not. Okay, this is house characteristics, which just to control, we are not much interested in them. This is also because of the different prices across space, we use this fixed effects, which are SA1 statistical area, to capture like spatial heterogeneity, and then there is temporal impact, which is price changes with time, and we have 10-year period, so for each quarter of year we gave a fixed effect, which captures the price trend. Also, what is not this is error. What is not shown is that some of the things sold several times. So it could be sold as lot, and then a house maybe several times house is sold. So this is a problem if you estimate model. You could either keep just one variable to get proper estimate of error, or in this case we assume that error is correlated between two observations which have a sale of the same house or same lot. Okay, so I'll show this result. I guess I'm a little too fast. Show these results in form of these graphs. Anyone familiar with these graphs? Okay, so log, you saw this equation, the dependent variable is log of price of house. Okay, and these are different variables. And on the x-axis is a coefficient, which is impact of this variable on the price. So for example, if this is lot area in hundreds of square meters, convenient kind of variable. So for each 100 of square meters, the price increases by 11%. Okay. So house versus just being house versus lot, because this is modeled for both lots and houses. The price is like 25% higher, but also the bedrooms, like not every bedroom adds like 2% to price, every bathroom adds like 5 to 10%, every carport adds some price. With age, every year we lose that much price. And then, if it's within 50 meters of public open space, then price about 3 to 4% higher. If it's 50 to 100 meters to public open space, it's about 1% higher. Okay, and if it's sold before or after construction of public open space, it doesn't matter, no impact. Okay, so this is just graph, and this is just basic model when we pulled all the data together and estimated just very basic, very few variables, just to have an idea. And we would not be interested in these variables because we are only interested in these. I'll show just these, and I show separately for houses, separately for lots, and separately for total for. And I'll be adding variables one by one. So we start from this one, just public open space, and then we add living stream. So second graph is similar model. Also we have 3 variables, and we have impact on x-axis, and we have green dots would be land, lots, and blue dots would be house, and total house and lots would be red dots. Okay, and these whiskers would be confidence interval, how we confident in this estimate. So 95% confidence interval. If it's like doesn't cross this dashed line, then we are good. If it crosses, then maybe not. We cannot tell that this actual impact exists. So same model, except that estimated separately for, and also it allows us to stretch. So like because there are high impact variable, we got rid of them, so we kind of see a little bit better what is actually impact. So 50 meters to public open space, lots about 2.5%, maybe 2.6%, and houses is like slightly higher, maybe 3 to 4%. But with houses we have bigger confidence interval because we have fewer observation houses. So for 50 to 100, we see significant impact, about 1% for pooled model, and for lots, but for house it's not significant. Also because we have few observation houses. And then whether it's sold before or after construction of living stream, regardless, basically we have no impact before or after POS or living stream construction. So people, if they know that something will be built, which would be nice, they're already willing to pay for this. Okay, next one is the add living stream. So this is impact of public open space, 50 to 100, 0 to 50, 50 to 100. 0 to 50 with adjacent and like it's next to adjacent. And on the top of that we add living stream. So this would be for all of the, whether it's living stream or public open space within 50 meters. And this would be plus impact of living stream. If this public open space happen to be living stream, we have additional impact of this. So what we see here is that we observe that for lots and for pool model we have statistically significant additional impact of about 1.3%. Okay, for houses it's not statistically significant at 5% level, but at 10% level if you relax our constraint, it's still there is about similar impact. Okay, so if we have living stream, it's about 1.3% higher impact on house price than its other public open spaces. Okay, and 50 to 100, no difference. Okay, and again, this variable of timing, it shows that there is no difference. Okay, so this one is, we add even more complication. You add this activated POS or living stream. Within 50 meters, activated POS or living stream within 100 meters, and it's not separately, it's in addition to that. So some of them would be the impact on the house which has within 50 meters public open space, which is happen to be living stream and which has some infrastructure, like playground, or barbecue desks, would have impact of this public open space, which is sum of this plus this plus this. Okay, and here we see that this become a little bit less, and the impact of living stream become a little bit less and even not significant, strictly speaking, for houses. But for pooled model, it's at 10% significant. But what we see that where that impact come from, it's from the existence or presence of this infrastructure on that lot, or on that public open space which is next to houses. So we can say that living stream is a little bit better than other public open spaces, but what makes difference actually that is being activated, which means having some recreational infrastructure on the lot. And again, we have no time, no difference for time. Okay, so that's what we found so far. So contribution of this study is that we estimate the value of benefits generated by living stream in new development, which is different to what we have in older suburb when we have retrofit living stream. And density of this public open space is different than here. And we estimated compared benefit of living stream and other types of public open space. We found that there is some difference, but it depends. How do we look at it? We estimated contribution of recreational infrastructure or activated POS and benefits of public open space. We also looked at the model when we looked at both impact of this POS or living streams activated on both houses and lots and together. And we also analyzed the impact of time of construction of living stream or public open space on the value of houses. We found that our model quite good. It explained about 86% of variance of variation of the local price, and the public open space add about 2 to 4% of value to houses, being immediately adjacent, and being farther away, the impact is much less. And then the additional premium to public open space, or public open space, comes from this public open space being living stream, so people like water, and also this public open space containing some recreational infrastructure, such as playgrounds or barbecue places. And also we found that this premium almost does not depend on the timing of construction of living. So if we know that there is a plan of constructing of this public open space or living stream, the people will be willing to pay higher price. So they pay for a lot, almost as high prices for houses if it's adjacent to public open space, and if even it's not constructed, they still pay about the same price. Thank you very much. And if you have any more questions or suggestions, I would be really grateful for that.